This lesson is about hyperbolas. Hyperbolas are kind of this shape that goes like this, which you can kind of see on an hourglass. Those are called hyperbolas, okay? Hyperbola, the official definition of it is the set of all points in a plane such that the absolute value of the difference of the distances between two fixed points, called the foci, is constant. And the foci, of course, is the two fixed points. That is a lot to take in. But basically, this is kind of what a hyperbola looks like, okay? The two red branches or curves are hyperbolas. Notice it's like two back-to-back, not back-to-back, but symmetric parabolas, okay? All right, some formulas and things that you need to be familiar with. First of all, here's a picture of a hyperbola. And it's got some important terms and definitions in there, okay, that we need to kind of talk about. This happens to be a hyperbola that's a side-to-side hyperbola, a horizontal hyperbola. And so these same vocabulary words work when it's an up and down hyperbola or a vertical hyperbola, but just so you know. So the vertex is kind of those points on both parabolas where they change directions. That's the vertex. The transverse axis, some people think by looking at this picture that the transverse axis is the long axis, and that's true in this case, but it's not always true. The transverse axis is the axis in which the hyperbolas, the two branches of the hyperbolas go on. Okay, so in this case, the two branches of the hyperbolas are symmetric around the x-axis. So the transverse axis is a horizontal axis or an x-axis. It does happen to be the longest in this case, but it's not always the longest. And then the conjugate axis is the opposite axis. So in this case, it's the up-down axis. Okay. These two fixed points here, of course, are called the foci. And then I want you to notice this. The distance A is always on the transverse axis, okay? So your equation will go like this if it's a horizontal hyperbola. Notice the A is below the X, and this is the case where this picture holds true, where your hyperbolas are two branches that are left and right. So it's a left-right hyperbola. Again, notice the x is listed first in the equation and that the a is underneath the x, okay? And that's how that will always work. If it was a hyperbola that went up-down like this, then this is the situation that would it would happen with. Okay, notice the y is listed first because it's an up-down hyperbola, but the a is still underneath the y, okay? So the a always is along the transverse axis, all right? So this distance from here to here is a, and this distance from here to here is b, and then this distance from the center to the foci is c on a hyperbola, okay? Notice you've got these two dotted lines right here, which are called asymptotes. Basically, the hyperbola, the branches of the hyperbola will continue to hug those lines, but it will never, ever, ever touch them on either branch. So those are called asymptotes, okay? And we can come up with equations for them. Notice they are lines, so we can come up with an equation in y equals mx plus b form, which we will do when we get to it, okay? So here's our first situation. I have graphed a hyperbola for you here, and we want to be able to come up with the equation for it. Notice it is a up-down hyperbola. It's a vertical hyperbola, so we are going to use this set of information right here on your master formula sheet. Okay, I can see that it is centered. The center of this hyperbola right here is at 0, 0. And so all of this is going to work fabulously. Because it's a vertical hyperbola, I know that I'm going to have y squared over something minus x squared over something equals 1. And I need to be able to figure out what that something is. Okay? Again, a is always the distance along the transverse axis, the distance from your center to your vertex of your hyperbolas. Okay, so my a in this case will be this distance right here. So my a is 3. Okay, and then what I know is I know that my c is this distance right here. So I know that my c is 4. What I don't know is my b, okay? But I do know that I can use Pythagorean theorem and I know that I can do a squared plus b squared equals c squared. And if you can't picture that, I don't have the asymptotes drawn in here, but I'll show you one later where I do have the asymptotes drawn in here, and you can see how you get a triangle out of this. So that will come in a later problem. But I am going to do a squared plus b squared equals c squared to figure out what b is. Okay, and I just said over here that a equals b. Sorry about that. A is not b. A is 3. Sorry. Anyways, so 3 squared plus b squared equals 4 squared. So b squared is going to be 16 minus 9, which is 7. And of course, b will be the square root of 7. But when you're looking in your little formula over here, what goes under here is a squared. Well, I know a is 3, so a squared is 9. And then I just solved for b, and I found that b was the square root of 7, but b squared, of course, is 7. So that is what that equation is going to look like. And so here is your equation for this hyperbola right here. All right, we are actually going to skip that. Okay, then it says find the coordinates of the vertices, the foci, and the equations of the asymptotes for the hyperbola, and then graph it. Okay, so notice that this equation here has x squared listed first, which means if x squared is listed first, I know the branches of my hyperbola are left-right branches instead of up-down branches. So I am going to use all of this information right here to help me. Okay, so I know again that this is a left-right hyperbola. I know that it is centered at 0, 0. I can see that a squared is 9. A squared is 9. So I know that a squared is 9. So of course I know then that a is 3. If I look here in the formula, b squared in this case is underneath the y, and b squared is 4. So b is 2. So what I'm going to do is I'm going to kind of start graphing this to help me here, okay? So I can know that my center is at 0, 0. Again, because my x is listed first, I know this is a left-right hyperbola. And so I know that my a has to be my left-right distance in this case, since it's a left-right hyperbola. So I am going to go 3 to the right of this center and make kind of a dot, and 3 to the left of this center and make a dot. And so I can see here that of course a is 3, and then b will be 2, so b goes along what's called your conjugate axis in this case, so this distance should be 2, so I'm going to go 2 up, 2 down, okay, and I'm going to make myself just a little box right here that connects all of those dots, okay? And then what I'm going to do is I'm going to draw in the asymptotes. And the asymptotes are going to connect this corner of the box and this corner of the box. And I'm going to make an equation, or a line, an equation based on this line. And then I'm going to draw another asymptote, obviously, that connects the other corners of the box. Okay? And then I know that this is a left-right hyperbola, so I know that my branches are going to fit in here. And my branches are going to hug that green line, but they will never touch it. Okay? So this is a graph of the hyperbola. And now what I need to know is I need to talk about the vertices and all of that good stuff. So here's your vertices right here. Okay, notice you started at your center, which is 0, 0, and you went 3 to the left. Sorry, and you know what? I went 4. I can't count very well. Oh my goodness, you guys. I better fix this. Sorry. It's going to be all messed up if I don't. I'm so sorry. 3 to the right, 3 to the left, 2 up, 2 down. Let's try this again. Sorry. Here's my box. Okay. Here's my asymptotes. All right, sorry about that. And here's your branches of your hyperbola. Okay, let's try this again. All right, so this point right here is your one vertex, and this point right here is another vertex. So you started at 0, 0, and then you went 3 to the left to get to this one, and you went 3 to the right to get to this one. So you have vertices um, at negative 3, 0, and positive 3, 0. Okay, so that's the first thing we're going to talk about. Then we want to talk about where my foci are. Okay, and I have to figure out, first of all, what C is. I know what A and B are, but I do not know what C is. So I'm going to figure that out by doing A squared plus B squared equals C squared. Okay, so let's see, 3 squared plus 2 squared equals C squared. 3 squared is 9, 2 squared is 4. So C squared is 13. So C is the square root of 13. If you get that as a decimal, um, the square root of uh, the square root of 13 is about 3.6. The only reason that's helpful for you is to be able to draw your foci in. So your foci is 3.6, which means that it's 3.6 away from the center. Okay, so if I start at 0, 0 and I go 3.6, that puts my one foci right about here and another foci right about there. Okay, so there's my foci. 3.6 to the left of the center, 3.6 to the right of the center in this case, since it's a left-right hyperbola. So, your foci. This point right here would be negative 3.6. And actually, I'm going to use square root symbols instead of the decimals. I just get the decimals to help me be able to put it on the graph pretty accurately. So I'm actually going to call that negative square root of 13, 0. And positive square root of 13, 0 would be the right-hand one. So there's the foci. Okay, and then the asymptotes, which you can get right here. We already know that B is 2 and A is 3. So your asymptotes will be positive or y equals positive or negative 2/3 x. Okay? And you can kind of see that because your rise over your run is 2 over 3. Makes sense. All right, so there's that one. Okay, that one was a nice pretty one because it was centered at the origin. They are not always going to be that nice and pretty. They won't always be centered at the origin. So we need to have some ways to kind of deal with this when they aren't centered at the origin. And that's what that formula thing was all about, okay? So now we're looking at this one. This particular one, you can see that your y is listed first right here. And so we are dealing with, in this case, an up-down hyperbola, and we are going to use all of this information over here on our master formula sheet. Okay, so the first thing I like to get out of here is your center. And your center is still h and k, always. Your center is always h and k. So in this case, your h is 1, and your k is negative 6. Your h always goes with your x, and your k always goes with your y, no matter which one is listed first. Okay, every single time. The h goes with the x, the k goes with the y. So I am centered in this case at 1, negative 6. So I'm going to kind of plot that point on there. 1, negative 6 would go right here. Okay. And then again, this is an up-down parabola. And A will be whatever direction the parabola goes, or hyperbola, I mean. So this is an up-down hyperbola. So that means A, the distance A, will go up and down on an up-down hyperbola. Okay? So, looking at my formula, A squared is here, and if I go over here, that's what this is. So I know that A squared is 20, so I know that A is the square root of 20, or, better yet, A is 2 root 5. Okay? Now, in order to be able to graph that pretty accurately, you probably want a decimal for that. And so a decimal value for the square root of 20 is 4.47, just so you know. So if you get the square root of 20, the decimal value for this is 4.47. Again, A goes along, in this case, is an up-down distance since this is a vertical parabola. So I'm going to go 4.7 up from here, and 4.7 down. And those are going to be kind of some markers on my box. And oh my gosh, I cannot count, you guys. Sorry, I graphed my first spot at 1, negative 5 instead of 1, negative 6. All right, 4.47 up and 4.47 down. Okay. And again, that's the same as the square root of 20. Okay, 4.47 is the same as the square root of 20, which is also the same as 2 root of 5. All right, then if we look at our formula over here, b squared is 25. Okay, so b squared is 25, and that means that b, of course, will be 5. In this case, since it's an up-down hyperbola, that is your left and right distance. B is your left and right. So I'm going to go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5 to the left. And this is going to kind of create my box for my hyperbola. Okay, I got a little off center over here on this corner, sorry. All right, let's try that. Okay, again, this is an up-down hyperbola. I am going to draw my asymptotes in here. Okay, and an up-down hyperbola, and it will go like this. It's kind of a wider one in this case. Okay. All right, so we need to find some things. First of all, let's talk about where our vertices are. Okay, so our vertices, obviously this is one of those points right here. Okay, now you need to think about where you are on the coordinate grid. So if you look at your x value, you know that you're 1 over. Okay, so I know that I'm 1 over. And then on my y value, my center started at negative 6. And then I went the square root of 20, which is also 2 root 5, up from that. So my center started at negative 6, and then I went 2 root 5 up from that. So it'll be negative 6 plus 2 root 5 for this vertex up here. And then, of course, if you go the other way, you're still 1 over. And then this vertex down here would be at negative 6 minus 2 root 5. And again, 2 root 5 is the same as 20, but I want it simplified as much as you can. Okay, so there's your vertices. Now let's talk about our asymptotes. Or not our, no, let's not do our asymptotes next. Let's do our foci next, okay? And in order to do our foci, we need to know what C is, all right? So I'm going to figure out what C is. I'm going to box this off so I make sure I have it. Okay, I'm going to figure out what C is. And again, you can do a squared plus b squared equals c squared. So c squared, a squared is 20, b squared is 25. So 20 plus 25 is 45. 45, sorry. So c is the square root of 45, which of course we know is 9 times 5 is 3 root 5. Okay, so c is 3 root 5. If you get the square root of 45 as a decimal, I guess I don't even know what the square root of 45 as a decimal is, but I can punch that into my calculator really quickly. The square root of 45 is 6.7 about. So you're going to go from your center, so you're going to start right here and go 6.7 up. So your foci will be about right there on the upper one, and then about right here on the lower one is your two foci. Okay? So here we go. Foci. Again, your foci, you started at 1 to the right, and then you went negative 6 plus the square root of 45, which is 3 root 5. And then for your other one, you started at 1 and you went negative 6 minus the square root of 45, which of course is 3 root 5. Okay. All right. And then your asymptotes, which of course are the green lines, you're going to use this equation right here, and you'll just plug everything in. Okay. So you'll have y minus your k value, which of course we know is negative 6. Y minus negative 6 becomes positive 6. Equals plus or minus your a, which you figured up above, was the square root of 20, which was 2 root 5, over b, which you know is 5, and then x minus your h value, which you know is 1. Okay? And that should give you your equation for your asymptotes. Okay? Which of course are the green lines up there. So, there you go. Now, I got to tell you this. If I wanted you to calculate, let's say, how long the transverse axis was, the transverse axis is this axis right here. It's always the axis that would connect your two vertices. If I wanted you to find the length of that, you know that from here to here is the square root of 20, and from here to here is the square root of 20. So total, that length would be 2 times root 20, or 2 times 2 root 5, which would be 4 root 5. And that might come up in your homework, just so you know. All right, then we have one where you're going to need to complete the square to be able to do this work, okay? And so let's run through that really quick. To complete the square, you're going to do this actually just a little bit differently here. You want to group your x's together, so I will have x squared plus 6x, and then my y's together, minus 3y squared plus 6y, and then you're going to want to move your constant to the other side. So on the other side, that'll equal positive 18. Okay? And now you're going to complete the square on the x's and the y's. Notice it's the y that's subtracted, okay? So it'll be the y listed second. So I could tell you right now my y is negative, and that means that it's going to be a left-right hyperbola, okay? So I know I'm going to be using this information. So this is what this is going to look like. X squared, and luckily the number that's right here is just 1, so I don't need to do anything special. So I have x squared plus 6x plus a blank, okay? Then out of these, I am going to factor out a negative 3y, okay? So I'm actually going to put this in parentheses just to clean it up right here. I'm going to factor out a negative 3, okay? And then negative 3 here, I'll have y squared, okay? And then negative 3 times negative 2y gives me positive 6y. So negative 3 times negative 2y gives me positive 6y plus a blank equals 18. Now, on the right side, you need a blank to match every blank that's on the left side. So I had one blank here and one blank here, which means I need a here and a here. Okay? I need however many I have on the left, I have to have that many blanks on the right. All right, now complete the square on the x's. So of course half of 6 is 3. When you square 3, you get 9. So I will put 9 there, and I will put 9 here. And then minus 3, don't forget to bring that down. And then half of negative 2 is negative 1. When I square negative 1, I get positive 1. But be careful, because what you really have to do here is you have to take negative 3 times 1, which is negative 3, and that's what goes over here. Okay? And then 18 plus 9 is 27. Minus 3, of course, is 24. And now in a hyperbola equation, of course, you need that right side to equal 1. So what you're going to do now is you're going to divide everything by 24. And you'll get x plus 3 squared over 24. The 3 and the 24 will cancel, and you'll get 8 over here, minus y minus 1 squared over 8 equals 1. Okay? So there's your equation for your hyperbola. Okay, I'm just going to kind of box this off to clean it up a little bit. So I'm going to start by sort of making a rough graph of this. Again, your h value always goes with this, so I can tell right here that and it goes x minus h, so in this case it's x minus a negative 3. So my h is negative 3, and of course I can see that my k is 1. So that tells me that my center is at negative 3, 1. I'm going to try to graph this correctly this time. Negative 3, 1 is my center. Okay? I can tell you right now this is a left-right parabola because my x is listed, or hyperbola, sorry, because my x is listed first. And I can see that a squared is 24. This will be your a value right here, which means a is the square root of 24, which of course breaks down into 2 root 6. If you get that as a decimal, 2 root 6 is about 4.9 or so. So again, this is a left-right parabola, so I'm going to move, my a value will go along my x-axis in this case. And I'm going to go 4.9 to the left and 4.9 to the right. Okay. This gives you your b squared value. So b squared is 8, which of course means that b is the square root of 8, which is also 2 root 2. Okay. And as a decimal, 2 root 2 is 2.8. So I'm going to go 2.8 up and 2.8 down from my center. And I'm going to kind of create my little box here. All right, so that should help. Here's your, oh my goodness, you guys, I am struggling here. 2.8 I need to go down. I only wanted to go down this far, sorry. Okay, there we go. Then here's your asymptotes. Okay, and of course I know that this is a left-right parabola, so not parabola, hyperbola. Okay. All right, so we've got that. Now we want to talk about our vertices and all of that other good stuff. Okay, so here we go. Our vertices. All right, so this first vertex right here, you can see that your y value, you're 1 up. So I know it's going to be something comma 1 and 1 up. Okay, my center started at -3 right here. And then if you'll remember, you moved this much, the square root of 24, or 2 root 6. So I started at -3, and then I subtracted 2 root 6, which is the square root of 24. Okay? And then, of course, you can go the other way as well. And I can go -3 plus 2 root 6, and then I'm still 1 up. Okay, so there's my vertices. In order to find your foci, of course, you need to know what C is. And so I'm going to go down here and I'm going to find C. So of course we know that a squared plus b squared equals c squared in this case. So you have 24 plus 8 equals c squared. So c squared is 32. And of course then c is the square root of 32, which is also 16 times 2, so that would be 4 root 2 if you wanted to get that exact value, is 4 root 2. As a decimal, the square root of 32 is, let me think, I gotta put this into my calculator. As a decimal, the square root of 32 is 5.65. So when you go to graph your foci, you're going to go 5.65 to the left and to the right of the center. So 1, 2, 3, 4, 5.5. I would have a foci about right there and about right there. Okay, are my two foci. All right, so again, for your foci, your y values are 1s because you're 1 up. And your foci would be the square root of 32, which of course we know is 4 root 2, to the left of the center. And the x value of the center was -3, so I'm going to go -3 minus 4 root 2. And then I was 1 up, and of course -3 plus 4 root 2. And I was 1 up. So there's your foci. Okay, and then to get your asymptotes, which are your green line, all right, your asymptotes, of course you're going to follow this handy dandy little equation right here. So you'll go y minus k. So in this case, that'll be y minus 1 equals plus or minus your b value, which is 2 root 2, over your a value, which is 2 root 6, and then x minus h, which will be x plus 3. Okay, now we need to simplify this because I won't let you leave radicals like that. So first of all, the 2's cancel. So that's good. And then you're going to multiply by root 6. And then you'll have this. On the top, you'll have the square root of 12. On the bottom, you'll have 6. Of course, we know that the square root of 12 is 2 root 3. And then, of course, the 2 and the 6 can reduce. So that's 1 and 3. So it really ends up as the square root of 3 over 3. Like that. You have to do a little simplifying there. Those radicals just keep coming back to haunt you. All right, lastly, this one goes quick, okay? Centered at the origin, it has a horizontal transverse axis. So the transverse axis is horizontal, which means it's a left-right hyperbola. Okay, so I can use all of this information right here. The horizontal transverse axis has a length of 12 units. So I'm started right here. The whole axis has a length of 12 units. Well, if you split that 12 units in half, that means you're going to go 6 to the left and 6 to the right. Okay? And then the conjugate axis is the opposite axis. It has a total length of 4 units, which if you split that in half means you're going to go 2 up and 2 down. So here's your little box right here. Okay. And we know that this is a left-right axis because it told me that the transverse axis is that. So now what I know is this. I know that A is 6, and I know that B is 2. Okay? And of course you would have your asymptotes here. And I know this is a left-right hyperbola, so it's going to go like this and like this. Okay? And here we go. I can make my equation. X squared over A, and A is 6, so 6 squared is 36. Y squared over B. B is 2, 2 squared is 4. And that's all you have to do. That will make up that equation right there. Okay? That should do it.